Good morning everyone. In previous class we discussed about the basis of design. In this class we discussed about condition to be satisfied to avoid a disproportionate collapse. Buildings should be effectively tied together at each principal floor level and each column should be effectively held in position by means of continuous tie. It is nearly orthogonal. Each story of the building should be checked to ensure disproportionate collapse would not precipitate by the national removal. One at a time of each column checks should be made at each story by removing one lateral support system at a time to ensure disproportionate collapse would not occur. So first of all we need to check that in every floor, every story of the building and each column of the building and how the lateral support we provide to ensure the disproportionate collapse would not occur. Then we discuss about action. Which action we consider in the case of partial safety factor to avoid the action. The first we discussed classification of action by their variation with time as given below. Permanent action which is denoted as QP, variable action which is denoted as QV and accidental action we denote as QA we discussed here. The three types of action is basically we consider. First permanent action which is permanently act on the structure which is action due to self-weight of structure and non-structural components, fitting and fixed equipment etc. And the variable action which is dependent on the action due to construction and service stage loads such as impose and leave loads and wind loads, earthquake loads etc. Then we discuss accidental action which is QA, action due to explosion, impact of vehicle and fire and etc. Then we discuss partial safety factor. It is the provided in IS 456-2000. The table is provided for the partial safety factor which we consider against the action. For the partial safety factor is provided for the limit state of strength and limit state of serviceability. The table we consider in case of design. Normally partial safety factor we consider in case of concrete base 1.5. But normally dead load, live load and wind load we consider. And the combination action load we consider for the total limit state of strength and limit state of serviceability. The load we consider which is dead load, live load and wind load and earthquake load we consider for the leading and accompanying is differently provided here. So we can consider from this table the load for the limit state of strength and limit state of serviceability against action. Then we discuss about partial safety factor strength. The here also a table is provided in the IS 456-2000. Serial number and definition partial safety factor we provided. Serial number 1, 2, 3, 4 are provided. Definition of resistance governed by yielding which is gamma m0. Resistance of member to buckling which is gamma m0. And resistance governed by ultimate stress which is gamma m1. Resistance of connection which is gamma m1. Partial safety factor for resistance we consider 1.1. Partial safety resistance of member to the buckling. Partial safety factor we consider 1.1. Resistance of governed by ultimate stress we consider partial safety factor 1.25. Resistance of connection, soft fabrication and field fabrication. Soft fabrication denotes as S and field fabrication denotes as NS. Both fabrication type for soft and field we provided here. But bearing type also provided here. Revelled and weld also provided here. This is we use that for in case of steel also. That is the partial safety factor for the strength. And before they will be discussed partial safety factor against action. Then we discuss the factor governing the ultimate strength. The frame stability against overturning and fatigue design shall be as per section 13 of this code, When designing for fatigue, the load factor for action gamma f equal to unity shall be used for the load causing stress, fluctuation and stress ranges. And plasticity collapse, plastic analysis and design may be used if the requirement specification under the plastic method of analysis are satisfied. We consider the factor which is governing the ultimate strength by the method of limit state method. Then we discuss limit state of serviceability. Then in limit state of serviceability, deflection are to be checked for the most adverse but realistic combination of service load. Their arrangement by elastic analysis using a load factor of 1.0 and suitable provision in the design shall be made for the dynamic effect of live load, impact load and vibration fatigue due to machinery operation loads. The durability of cell structure shall be ensured by following recommendation of section 15 of IS 456. Then design provision to resist fire and briefly discussed in section 16. For the limit state of serviceability, the details of the design provision is provided here about just about fire and provide proper safety. We can consider from the IS 456. Thank you. The second chapter is completed. The remaining part we discussed, remaining chapter which is chapter 3 up to chapter 8 we discuss next class. Thank you.